Have you ever considered the invisible workhorses of industry? The humble boiler, for instance. It's like the beating heart powering everything from, the steam that processes our food to the electricity lighting our homes. But have you ever actually thought about what keeps that vital heart running efficiently day in, day out? Okay, let's pull back the curtain. Today, we're taking a deep dive into the surprisingly dynamic and really essential world of boiler water treatment chemicals. It might sound a bit niche, I guess, but these compounds are, well, fundamental to countless industries. We've got some pretty illuminating sources here, mainly a detailed market research analysis from cognitive market research to guide us through this.
Yeah, and our mission for this deep dive is really to understand the current landscape of this critical market. Get a feel for it. We'll look at its key trends, the significant environmental challenges it faces, and importantly, where innovation is steering its future. What's truly remarkable here is how seemingly minor chemical adjustments, tiny tweaks, can have these massive implications for operational efficiency, cost savings, and even, the health of our planet. This should give you a vital shortcut to being well-informed about an often overlooked but honestly profoundly impactful industry.
So, why do boilers even need chemical treatment in the first place? I mean, it seems like such a basic piece of equipment, but water in its natural state.
It can be quite the enemy, right? Exactly, that's the core of it. While boilers are integral to so many sectors, you mentioned power generation, food and beverage, chemical processing, the impurities that are just naturally present in water lead to this constant battle, a battle against common adversaries. Corrosion, scaling, deposits, things building up. And these issues don't just reduce efficiency, they can literally choke a boiler's performance and drastically shorten its operational life.
Okay. And this is where these specialized chemicals step in then.
Precisely. Boiler water treatment chemicals are absolutely critical for maintaining that operational efficiency and, crucially, extending equipment longevity. When you compare them to older methods, maybe like mechanical cleaning, which can be really labor-intensive and disruptive, these chemicals offer a far more consistent, effective, and kind of continuous protective layer. It makes them truly indispensable. In fact, our sources indicate that as of 2024, they already account for roughly 40% of the overall industrial water treatment chemicals market. And that share is projected to rise slightly, maybe to 42% by 2025. That's a really significant slice of a very large pie.
Wow, okay. So, if these chemicals are so indispensable, what's the actual scale of this market? Just how big is this unseen industry we're talking about?
Well, it's growing at a, frankly, impressive rate. The global market for these chemicals isn't just stable, it's experiencing consistent and robust expansion. We're talking an estimated value of over 4.5 billion US dollars in 2024. And it's projected to skyrocket to over $10 billion by 2032. That represents a compound annual growth rate, or CAGR, of about 10.6%.
10.6%. That's a staggering growth rate for something that, like you said, often flies under the radar. What's propelling this kind of momentum?
Yeah, it's significant. And if we connect this to the bigger picture, this kind of growth isn't accidental. It's definitely not. It's propelled by a confluence of global factors, rising demand for energy across the board, for one. Then there's rapid industrialization and urbanization, particularly in developing economies. That's a huge driver. And crucially, we're seeing more stringent regulations around industrial emissions and water quality worldwide. Beyond that, industries themselves are increasingly focused on energy efficiency and cost reduction, which these chemicals directly support. It really makes you think, doesn't it? How this market's growth kind of mirrors evolving global priorities for sustainability and productivity.
Right. So beyond the raw numbers, the billions of dollars, what are the defining trends shaping this market right now? What are industries demanding from these chemical solutions today?
Well, our sources highlight a really strong drive towards greater energy efficiency, definitely. Sustainability is huge, too. And increasingly, customized solutions, tailored approaches. Industries are actively looking to optimize their energy consumption and, let's be honest, slash operating costs. And that directly translates into a demand for chemicals that can improve heat transfer and minimize energy losses within their boiler systems. It's really about getting more bang for your buck or more out of every drop of steam, perhaps.
That sounds like a clear win-win situation. And given the global focus on environmental concerns, I imagine there's a strong push for greener alternatives as well.
Absolutely. Yeah, that's a huge factor. One particularly compelling aspect is this growing emphasis on environmental conservation. It's really spurring the adoption of eco-friendly and biodegradable chemicals. You see manufacturers really stepping up, developing formulations that aim to balance high performance with a significantly reduced environmental footprint. It's a crucial balancing act, definitely, but one that's gaining serious traction.
Okay, so how are companies making sure these, precise, sometimes eco-friendly chemicals are actually used effectively? Is technology playing a part in that?
Indeed it is. There's also a really significant trend towards integrating real-time monitoring technologies, sensors, data analytics. Now, what this means for chemical usage is a radical shift, moving away from guesswork, maybe scheduled dosing, towards real precision. It allows for optimized dosing, which greatly enhances effectiveness and, crucially, minimizes waste. Reduces chemical overuse. It's really about intelligence meeting chemistry, you could say.
And when we look at the global picture, the landscape, are there particular regions that are sort of leading the charge, or is this growth pretty evenly distributed?
No, it's definitely not even. The market shows quite distinct regional growth patterns. Asia-Pacific currently leads the pack by a fair margin, holding approximately 45% of the global share. That's largely driven by the sheer scale of rapid industrialization happening in countries like China and India. Just massive expansion. North America follows with nearly 25%. That's mainly due to its mature industrial base, but also, significantly, its strict environmental regulations pushing for better treatment. Europe accounts for about 20%, fueled by its well-established industrial base and, similar to North America, a strong focus on sustainability. The rest of the world then makes up the remaining 10%. So it paints a pretty clear picture of how global industrial demand and, importantly, regional environmental policies are really shaping this market.
Interesting. So who are the big players then? Who are the major companies in this vital market, and how are they navigating what sounds like a pretty competitive landscape?
Oh, it's certainly a dynamic arena. Very competitive. Our sources highlight some key giants, names you might recognize. Ecolab Inc., for instance, held about 17% market share back in 2023. Salinas LLC was around 12%, and Veolia Water Technologies at about 8%. What's particularly interesting, though, is how these established companies are heavily investing in R&D. Research and development is key, and they're also pursuing strategic mergers and acquisitions to not only maintain their leadership position, but really to stay ahead of the curve. This is especially vital as new entrants emerge, particularly in those rapidly industrializing regions like Asia-Pacific. These newcomers often bring innovative approaches, or sometimes just compete very aggressively on cost. Keeps everyone on their toes.
Right. Now, while these chemicals are clearly critical for industrial efficiency, no solution is perfect. It's never without its downsides. What are the key environmental concerns associated with boiler water treatment chemicals? What's the flip side?
That's a crucial question, and it brings us right to this balancing act between industrial necessity and environmental protection. The usage of certain chemicals, things like phosphates, which are fantastic at preventing scaling and keeping pipes clear, or amines and various oxygen scavengers. Their use can contribute to water pollution and ecosystem disruption if they're not handled with extreme care, particularly during disposal. For example, phosphates, if they get into water bodies through improper disposal, can lead to eutrophication. That's that excessive algae growth which then depletes oxygen and seriously threatens aquatic life. This is exactly why we see stricter regulations emerging, like the Clean Water Act in the U.S., designed to directly address these kinds of impacts.
That's a really stark reminder of the downstream effects.
Okay.
Beyond the chemicals themselves, our sources also highlight this challenge of boiler blowdown water. For those less familiar, could you explain what exactly that is and why its disposal presents such a significant hurdle?
Right, boiler blowdown. It's actually an essential process for controlling the concentration of impurities inside the boiler system. You basically have to periodically purge out some of the boiler water to get rid of accumulated solids and dissolve minerals that concentrate over time. However, the water that's released, the blowdown water, often contains this complex cocktail of stuff. Dissolved and suspended solids, sometimes heavy metals that have leached from pipes, and of course, residual treatment chemicals. So improper management of this blowdown water can lead to serious soil and water contamination. Studies have even shown elevated levels of things like lead in discharge areas. The real challenge here isn't just getting rid of water, it's managing this contaminated effluent. And that necessitates significant investment in often quite advanced wastewater treatment systems before discharge is allowed, which of course adds to the operational costs for these industries. It's not
It
safe.
makes sense. And it's not just the usage and the disposal that have an environmental footprint, is it? What about the production of these chemicals themselves?
That's absolutely right. You really have to consider the entire life cycle. The production of many of these chemicals is often quite energy intensive. Plus, it frequently relies on non-renewable raw materials as feedstocks. Furthermore, you've got the transportation and storage of these chemicals, often in bulk, which contribute to greenhouse gas emissions. The whole supply chain. These concerns, added together, are a primary driver behind that push we talked about for more sustainable, biodegradable options. Though it's probably worth noting that sometimes these greener solutions still come with trade-offs, maybe in terms of initial cost or sometimes performance compared to their traditional, well-established counterparts.
That's a crucial point. So are we seeing widespread adoption of these sustainable options despite maybe some of those trade-offs? Or is the industry still, heavily reliant on the less eco-friendly but perhaps more cost-effective solutions for now?
It's still a bit of a mixed picture, frankly. There's definitely strong interest, and R&D in green chemistry is accelerating.
Hmm.
But widespread adoption faces hurdles. For many industries, especially those operating on really tight margins, the immediate economic viability of switching away from established, often cheaper formulations remains a significant factor. Let's be realistic. However, the pressure is mounting. Regulatory pressures are increasing, and growing corporate sustainability mandates, ESG goals, are definitely pushing the needle. It's moving things forward, albeit perhaps not as quickly as some environmental advocates might hope.
Hmm.
Progress is being made, but it takes time.
Okay. So looking ahead then, what does the future hold for this vital industry? Our sources point to some truly exciting advancements on the horizon. What's the technological roadmap looking like?
Yeah, the market is really poised for significant advancements, I think. Moving beyond just incremental improvements we've seen in the past, we're witnessing a clear progression from maybe traditional sort of blanket solutions towards highly sophisticated chemical formulations. And this is all being driven by that increasing priority on efficiency, sustainability, and just sheer operational reliability. Downtime is costly. For instance, the sources mentioned that in January 2024, a company called BV Water introduced some innovative formulations. These were designed not only to enhance efficiency and minimize scaling, but also to actually extend equipment lifespan, all while incorporating more eco-friendly compounds. So hitting multiple goals, it shows a clear direction of travel for the industry.
That's really encouraging to hear. What's another key trend shaping the market's evolution? Maybe something that changes how these chemicals are even managed day to day.
Well, what's truly remarkable, I think, and potentially game-changing, is the deepening integration of digital technologies in real-time monitoring systems. These advancements, they enable incredibly precise control over chemical dosages and overall water quality. Real-time adjustments. This significantly improves efficiency and can radically reduce waste, preventing over- or underdosing. These smart technologies, leveraging sensors, data analytics, maybe even AI, are becoming absolutely critical for industries moving towards smart manufacturing concepts, Industry 4.0. And looking even further ahead, innovations in things like nanotechnology, designing materials at the molecular level, and advanced bio-based formulations derived from renewable resources. These are expected to bring even more targeted, more effective, and hopefully more environmentally benign solutions to the forefront in the coming years.
Wow. This deep dive has really shown us how the boiler water treatment chemicals market, while, yeah, perhaps unseen by many of us, is evolving so rapidly. It seems like it's fundamentally at this intersection of technological advancements, really pressing sustainability goals, and that constant industrial need for optimized, efficient operations.
Exactly. And if we connect this back to the bigger picture, it really underscores how industries are adapting, maybe sometimes forced to adapt to meet these dual challenges,
Mm.
operational efficiency and environmental responsibility simultaneously, from energy conservation efforts to the rise of green chemistry principles and harnessing the power of AI-driven analytics. This market really serves as a fascinating microcosm of broader global industrial transformation. It's all happening here too.
So, for you, our curious listener, as industries become even more digitally integrated and, well, environmentally conscious, how might the role of these invisible chemicals continue to evolve? How will they shape the future of global manufacturing and energy production? What new innovations might emerge when, as we've heard, a tiny chemical adjustment can have such massive implications? Keep exploring, keep questioning, and join us next time for another deep dive into the fascinating world around us.